Summarising data, example 8. We're moving on to a slightly different representation of the data here because we're looking at data that is grouped. Now, if you think back to one of the earlier examples in the booklet, I think it was example 2, we looked at different ways of representing group data, and we looked at class boundaries and that sort of thing. Just before we start this question, there is an error here at the bottom. That should say 61. So if you haven't already corrected that in your notes booklet, correct that now. So, similar kind of strategy to what we've done before. We're asked first of all to estimate the mean number of correct answers. Now we're asked to estimate it because we don't actually know the exact data. All we know is that there are, for example, 4 entries between 0 and 5. But we don't know exactly what they are. So our answer can only ever be an estimate. Now what we do is we say, well, if there's 4 values between 0 and 5, a reasonable number to use to approximate them by would be the midpoint, and the midpoint of 0 and 5 is 2.5. So in this column here, I'm going to write at the top midpoint. Okay. Similarly, between 6 and 10, the midpoint of those is 8. If you remember, the quick way to work it out is to add the end 2 points together and half it. So 6 add 10 is 16 and half it is 8. Next one down, if you do the same thing, add them and half it, it's 13. Next one, 16 to 20, the midpoint is 18. Next one, 21 to 60, if you add those together and half it, you get 40.5. And then the last one, 61, remember, to 70 is 65.5. Now you might be thinking that I haven't written down the correct boundaries here, but the midpoints would still work out to be the same. So for example, in this interval here, if you remember that when there's a gap, we go halfway either side. So the boundaries here are actually 10.5, 10.5, 15.5, and so on. But if you were to do the same thing, add together these outside 2 values, the class boundaries, and half them, you'd get the same thing. So it doesn't matter whether you use it as the data's given or whether you go out halfway to the side like I'm doing here. Okay, this one will be 5.5. You might have wondered why I didn't start at the top. Well, because here, what would we put? Do we put minus 0.5? Sometimes you see that in a textbook, sometimes you don't. If you're going half out either side, we should strictly write minus 0.5 here, but obviously you can't get a negative number of questions incorrect. So for this first one, it's a little bit safer just to look at the original data. Okay, so we've got the midpoints. Now, if you remember, the formula for the mean is the sum of, now we normally say x, so I'll leave that a second, sum of x divided by n. Now here, what we're actually saying is that we're going to assume all the values in the first one are 2.5, and we've got those 4 times. Then we're going to assume the next one is 8, and we've got that 15 times. So we're actually going to do the frequency multiplied by the midpoint, and you probably remember doing that at GCSE. So we've got 2.5 4 times. We've got 8 15 times. We've got 13 5 times. 18 twice. We've got 40.5 0 times. There's nothing in that interval. And 65.5 once. So we would add up all of that and then divide by the number of values there are. Now, it's not the number of intervals, 1, 2, 3, 4, 5, 6. It's not 6, it's the sum of this column, sum of the frequencies. And if you add those up, I think that comes to 27. And doing all of that on your calculator, I got 10.98. A little bit extra. So to 3 significant figures, it works out to be 11. And that seems reasonable. It's in that big area there. Okay. Now, part B is asking us to find the median. Now, when it's grouped data, we have to use something called interpolation. And we're going to make an estimate of where the median lies within an interval. Okay, so let's have a think about it. We always start by working out n over 2. That will be 27 over 2. And 27 divided by 2 is 13.5. Now, normally, we would round this up and call it the 14th. But when we're doing interpolation, you don't round up. So we're going to leave it as the 13.5th value. So we've got to try and work out where that would be. So up at the top here, I'm going to do, like we did on a previous example, cumulative frequency. That'll help us work out whereabouts roughly the median is. So if I just go down this column, I'm adding up the frequencies as I go along. So this will be 26, that's still 26, and that one will be 27. Okay, so what we've got to do now is do this process called interpolation. The 13.5th value would lie in this interval here. We've got 4 in the first interval, and by the end of the second interval we've got 19 values. So 13.5 value will be somewhere in here, and I'm going to draw a little diagram. I find a diagram useful. So I'm drawing a diagram of this second interval. Now if you look, the boundaries of the second interval are 5.5 up to 10.5. And if we look at the cumulative frequencies, at the beginning of that interval, we had 4 people. By the end of that interval, we've got 19 people. So person number 13.5, which is what we're after, is going to be somewhere around about there. So I'm going to guess it's going to be somewhere around about 8, 8.5, something like that. So we're going to do a little calculation to work it out. And if you look back onto page 9, there's a calculation there. So in the box it says you start with the lower class boundary. So the lower class boundary is 5.5, and you add on to that the frequency you require out of the frequency in the chosen interval. Now let's see what that means. So the frequency we require, well, we had 4 up the beginning of this interval, and we want to get up to 13.5, so the frequency we require is from 4 to 13.5, that's 9.5. So we want 9.5 people out of how many there were in this interval. And if you look up at the top of the frequency table, you'll see that there were 15 people in this interval. So of those 15, between 4 and 19, we want 9.5. Okay, so it's the frequency we want out of the total frequency in that interval, and you multiply that by the class width. Now, the class width here is 5.5 to 10.5, so the class width is 5. Okay, now using our rules of BODMAS, we work this bit out first, and then we add on the 5.5. So if you use your calculator to work that out, 8.67 is the answer. So they're quite different. The mean is 11, and your median is 8.67. Okay, that's a process you really need to practice, that process of interpolation. And one of the crucial things to remember is we don't round. So that 13.5, you don't round it up. Part C, state whether the median or the mean is a better representation. Well, if you look back at the table, we've got 4 values, then 15, there's a lot in this interval, then 5, then it sort of diminishes a bit, then there's a big gap from 21 to 60, and then there's just one person in this top interval from 60 to 70. So what this shows us is that there's one student who was really good at answering these questions. It's an extreme value, and if you remember, we talked about this on a previous example. That extreme value has added a large amount to the total, and so it's dragged up the mean. It's dragged up the mean to 11, which makes it look like the average is round about here, but actually it should be where the median is, somewhere in this interval, 8.67. So give a reason which one is the best. So the median is a better representation as it is, can you remember that phrase from earlier that I said learn, not affected by outliers. And we have one outlier in this case, which is that really large value at the top. Again, it's a standard answer, so you need to try and make sure that you learn that. So it's a really, really good idea to go and look at exercise 2D now and make sure you practice lots of interpolation. It comes up every year.